Okay, and last but not least, the end of 7.6. We've got just a bunch of equations solving for x. We want to isolate that. So this should actually be pretty easy. The first thing I'm going to do is subtract 16 on both sides. So 5 minus 16 is negative 11. I'm going to divide both sides now by negative 3. So negative 11 divided by negative 3 gives me, it's 3.67, but I'm going to keep that number on the calculator. Okay, so I'm not going to clear it or anything. I'm not going to retype it. Now, in order to get rid of this e, what we can do is take the natural log on both sides, because the e and the natural log cancel each other out. I forget which lesson it is. A couple videos back I explained that briefly. So what I'm left with on the left is 2x. That canceled. So what I'm going to do on the right is take the natural log of this big decimal. I've already got it there, so I'm going to hit natural log, but instead of typing blah 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 like that, and clear, I'll just do that. I'm going to hit natural log, and then what you can do is hit second, and then right here you see A and S stands for answer. And basically what I'm doing now is I'm taking the natural log of this whole thing as it goes off forever and ever and ever. So it's a much more accurate answer. So that's going to be my answer on the right. And again, I'm just going to write 1.3 for now. To solve for x, I would want to divide both sides by 2. So again, I'm not going to retype anything. I'm just going to hit divided by 2, and this is going to be completely accurate as opposed to just an approximation. So I'm going to say 0.65 is my answer for x. Slightly different type of problem. These are actually super easy too. If you have a log with a base and a log with a base, as long as that base is the same and they're on opposite sides like this, I can cross that part out and just be left with the inside 6x. Now I'm going to subtract 5x over here. 6x minus 5x is just x, so x equals 9. Same thing, there is no base, or we know that the base is 10, but those just cancel out. So I have 12x minus 11 equals 3x plus 13. I'm going to subtract 3x from both sides, and I'm also going to add 11 here and here. Divide both sides by 9, so I get that. Again, this can be simplified because those are both multiples of 3. So divide by 3, and I get x equals 8/3. Alright, slightly different problem because there's only a log on one side. So this is actually like, if you look at video F, 7.6, the first video for 7.6, we rewrote things into log form. Here we're going to rewrite it into exponential form. So I have 4 to the first power equals x, which just means x equals 4. That one's done. That's easy. Slightly different. What I want to do is, I'm first going to divide both sides by 5. So I have that. Now, we did this, where was it? Right here. How E and ln canceled out. So what I can do, if I raise e to both sides, so e to the ln of x and e to the 5th, e and ln will cancel. So x equals e to the 5th. This is what I was left with. There's the x. And this is a calculator problem. So right above the ln is the e. So I'm going to hit second ln. and you'll see it goes automatically to the exponent. So I'm going to hit 5, and I get 148.4. Okay, this is your challenge problem. We're going to kind of combine lots of things here. First thing is, this is a condensed problem. I have two logs that are on the same side, so the only way I can deal with this is if I combine the two logs. So going back to 7.5, adding tells me I'm going to multiply. So I'm going to have 3x times x minus 1 equals 3. So let's just simplify this. That's 3x squared minus 3x equals 3. Rewrite this into exponential form. So I have 6 to the third equals 3x squared minus 3x. Six to the third is 216. What I'm going to do is bring the 216 to this side. So I just subtracted the 216. Divide everything by 3 so that you just have x squared. This gives me 72. And now, going back I think to chapter 3, if you factor this, we get x minus 9 times x plus 8, which means x equals 9 and negative 8. And that's your challenge problem.